Okay, chapter 11, variable acceleration then. So the first thing to note is the title, variable acceleration. This is versus the constant acceleration that we saw in chapter 9, and it was also used quite a bit in chapter 10. Okay, so we can sort of divide chapters 9 and 10 versus chapter 11, which is quite distinct, really. What's the difference? What's the impact of the difference? Well, constant acceleration, of course, gave you your Suvat equations, if you remember. So for variable acceleration, we're not going to be able to use those. Instead, we use differentiation and integration. So let's start by talking about functions of time. So we've talked a lot about displacement, velocity, acceleration. These are all things that are functions of time. Okay, in other words, depending on what the time is, the velocity will be different, or the acceleration will be different, and so on and so on. We looked at this a little bit when we talked about the graphs, like a velocity time graph. However, they don't always have to have this constant element. So look, for each section here, 1 and 2 and 3, they had their fixed acceleration, constant acceleration. For something like this, though, it's variable. Every different moment of time here has a different velocity. So it's accelerating because it's going up, but it's accelerating in a different way at those points. So you could draw a tangent, which is what you did at GCSE, to work with that a little bit more. But what you'll see is actually we can use differentiation and integration if we want to work a little bit more with this instead of areas under and gradients and stuff. Of course, if we just want a velocity and we have our time, plugging in a time there gives us a velocity. A couple of examples. So velocity equals half t cubed. What velocity after 4 seconds? Well, you put the 4 in. You just put the number 4 in. You substitute it in. How many seconds have elapsed when the velocity is 108? Well, the velocity is 108. What is t? So you solve that one backwards. Times by 2 both sides, cube root for 6 seconds. A couple more examples here. So a body moves in a straight line such that its velocity at time t is given by this equation here. Okay, so find the initial velocity. Remember, initial means t equals 0. If you want the velocity, that's v equals, so put 0 in. Well, you're going to get 24. Hopefully you can see that. The y-intercept's 24. Now, let's think about this a little bit more. So this is a bit more complicated than just a particle going to the right-hand side. What are the values of t when the body is at rest? Well, you can see initially it's not at rest. Initially, it had a speed of 24. So why would it sometimes be at rest? Well, it's easier to see if you sketch out that graph. I don't know exactly what this looks like. I know it starts at 24 and its velocity is a quadratic. So I'm going to assume that it has 2 roots. It will look something like this. And that's v. So there are some values here when it has a velocity of 0. And velocity of 0 is what it means when we say it's at rest. So we set the v equal to 0, and we're actually going to solve this quadratic here. Notice it simplifies by dividing by 2 to t squared minus 8t plus 3. Okay, if you solve it, t squared minus 8t plus 12, we get values of 2 and 6. So there are 2 times where the velocity is 0. What's happening is it has a positive velocity here, so it's moving to the right, and then it's reaching 0, and then it's negative. Negative means it's going to the left, and eventually there it goes to 0, and then the velocity goes up, so it goes like that. So this particle here does quite a lot of back and forth. Okay, and when it's going in between those back and forths, that's when the v is 0. What's the greatest value of t when the velocity is 64? So again, we plug 64 in, we work backwards. The value. So we've got two answers there. Time cannot be negative. Work it out, but then cross it out and say it's not valid. And finally, the greatest speed of the body in the interval 0 to 5. Well, that's 0. And here is 5 here. Now, the problem is, I know that's 24. I know that's 0. I don't actually know the speed at that point there. I know it has a negative velocity, but I need to work out this minimum point here. So if you have an interval, my general advice would be find the start, find the end, and find any turning points in between. So that turning point there you would need to find as well. Here they talk about doing it by symmetry. The symmetry between 2 and 6 is 4. If you put 4 into the equation itself, you'll get -8. So what's the greatest speed between 24 to -8? Well, it's 24. So the answer is just 24, but it won't always be this one. You have to check that that's correct. Okay, and that should take you to exercise 11A.